So the title of my talk is, what is ReasonML? And ReasonML is a new programming language by Facebook. The nice thing about it is that it supports several styles. So usually I think for many, if not most tasks, you will use a functional programming style. But occasionally it's actually really nice to also have the ability to do something imperative with mutable states. And if you want, you can also program in an object-oriented style. And there again, you can choose to either not have any mutable state or have mutable state. And if you had to quickly describe what ReasonML is it's basically a different syntax for OCaml. And this ML is already kind of a clue at a language of functional programming languages, and those are the ML family, and that is an abbreviation for meta language. And it's kind of weird if you follow both functional programmers and machine learning people, and they both use the abbreviation ML, but it means different things in different contexts. So this is a quick diagram of how ReasonML fits into the OCaml ecosystem. And so what you have here is what already existed, like this tree here is what already existed before ReasonML, and then this box up there is what ReasonML brought to the table. And the whole pipeline works like this. You have source code in OCaml syntax that is transformed into an abstract syntax tree, so compiler stuff. And then at the, that's as a brief explanation of what it is. And then at the end of this kind of compiler pipeline, you have three different backends. One of them is OCaml-C that produces bytecode. The other one is OCaml opt that produces fast native code. And the third one is BuckleScript that produces very readable JavaScript. And the new addition now is ReasonML syntax. And you parse that syntax, and then you become part of the already existing pipeline, which is nice. And that's actually a big plus of ReasonML because they're not reinventing the wheel. And with already having something that is very stable and very proven, you have a big advantage because that is kind of settled. And then you can focus on innovating in other areas. And this is a first quick look at what ReasonML looks like. And you can see that this is an interesting mix. On one hand, this syntax, for example, here you have an arrow function. It looks a bit like JavaScript. But on the other hand, the style is also quite functional. Because what you have here, for example, is a variant. And that is a kind of data structure that is very typical for functional programming. And what's also nice is that the way OCaml is built is you need very few type annotations. So this code you're seeing here has already all the typing information necessary implicit in how you use, for example, node up here. And then you get source code that looks untyped, but due to type inference, it's actually typed. So you get more security, more type safety. Okay, a few words about the foundation. Well, as I said, it's something proven. It was created in 1996 at INRIA in France. So it's existed almost as long as JavaScript, which was created in 1995. It's used extensively at Facebook and at Bloomberg and Jane Street and other companies. And the interesting thing about Bloomberg and Jane Street is that those are trading companies. So they need to write fast code. And that is always an option you have. So that is one of the big pluses of ReasonML, because you learn one programming language and you can write code for the web, but also really fast native code. And there's already one game out there by Jared, and that runs natively on Windows and on macOS, and also natively on Android and iOS, and also on the web. And that is based on GL. So when you compile native code, it compiles to OpenGL, and when you compile it to the web, it compiles to WebGL.
Published on the App Store.
Oh, it even, okay, that's nice.
In both App Stores it's published.
Yeah. So that's pretty amazing. And another big plus is that the whole build process for JavaScript code, so if you use ReasonML to produce JavaScript code, that is very fast. For example, a lot faster than TypeScript. And that also makes it an intriguing tool for front-end programming. The focus on ReasonML, because due to having OCaml that takes care of the foundations, ReasonML can focus on other things. And one of the foci is, I looked it up, those are the three plurals and the three ways of pronouncing the plural of focus. So what they're focusing on is tooling, and there was already work done for OCaml before that. So if you want to program in ReasonML, you can use Visual Studio Code, and it works really, really well. So whenever you have auto-completion, you can, within a file, you can do some simple refactorings. You get you get the type signature, and I think even some documentation, even if you hover on something. Who of you have used Visual Studio Code already? So that is a highly recommended, really nice IDE from Microsoft that's free and runs on several operating systems. And the good tooling is also available for OCaml. So ReasonML builds on the foundation that's already available. It was also like a collaborative effort to make that happen. Another thing that ReasonML focuses on is the interoperability with JavaScript. So that will always be a focus, and that was also part of the reason to change the syntax. And so with the syntax, you win some and you lose some. So one loss is that this kind of having no parentheses in OCaml is for many functional things actually nice. But on the other hand, OCaml has some syntax stuff that is a bit less consistent and not as nice. And this is where ReasonML cleans up. So you get some cleanups, and in some ways the syntax is more consistent. And you have another big advantage. If you switch between JavaScript and ReasonML very often, you already have familiar syntax. And it's and I think also if you want to teach someone, for example, functional concepts, ReasonML is a nice option because you can teach people about, say, recursion or maybe tail recursion or monads or what have you. And you can do it in syntax that they've already seen. So that's also a benefit of the syntax. Another focus is on React. So there is built-in support for JSX, for example. And another focus is to improve the standard library. There are several competing standard libraries in the OCaml world. And ReasonML wants to have a single unified very complete standard library. And that is something that I occasionally miss when I'm programming JavaScript, is a more comprehensive standard library. For the future, very quickly, so these are still a few weaknesses, but in the end, like, the future looks bright because all of these are being worked on. And if it were up to me, right now, it's ReasonML is, I think, mainly interesting for early adopters, for people who want to try something new. And but I think in a few months that will change. And once all of these pieces are in place, then it's going to be a really compelling solution. And if you already start programming with it now, you will have a head start compared to the other people who will come in later. And I think there will be a lot of them. So current weakness is, well, it's not that big a weakness, but it's still will be improved. There will be better support for JS promises, for JavaScript promises, and asynchronous programming. The JavaScript library is currently a work in progress. It's currently not always cross-platform, so sometimes you have to distinguish, do I compile to JavaScript, then you use other things for strings and for regular expressions, and all of that will go away in a few months. Better support for Unicode, that's also something that's being worked on. Currently, if you're compiling to JavaScript, and that is the default mode at the moment for ReasonML. So it's at the moment, ReasonML is very much based on JavaScript and NPM. Then you have a special string literal for Unicode aware strings, and then you'll be fine. There will also be better support for overloading. So in Haskell, these are called type classes. So you will be able, for example, at the moment you have different operators when it comes to plus for integers. So that's this plus here. And then you have a different plus for floating point numbers. That's the plus dot. And in the future, there will probably be support to overload, and then you could have, if you wanted to, a single operator for both. And one really neat idea that I've heard of, that's also something that they want to have eventually, is a truly native React Native. So you will be able to program native code in ReasonML, and you will be able to use React Native to program a user interface, but there won't be an intermediate JavaScript layer. So you'll work with it directly. And for cross-platform native programming, that'll be pretty awesome. And long-term, there will also be support for multi-core via algebraic effects. But that is long-term. Reason React is something that I find quite interesting because they're taking a slightly different approach to React JS, to React in the JavaScript world. They're taking more of a batteries included approach. So if you use Reason React, there's already a router included, and there's already a lightweight Redux included. And I think that's pretty cool because there's less choices that you have to make. And these things are also nicely designed to work well in the context of a functional programming language, so that's cool. And I haven't used it myself, but I've heard a lot of good things about GraphQL PPX. So that is kind of like a macro for GraphQL, where you immediately get static type support via in the code just by using GraphQL. So that is also very nice. A few tips for getting started. There are two ways in which you can try it out interactively. If you install the ReasonML tools, you have an interactive command line. That's actually also quite neat. For example, you type something, you get a syntax error, and then in the terminal, there's an underline where the syntax problem is. So that was something I hadn't seen before in a terminal. Not like I had seen underlines, but not underlines in the context of an interactive command line. You also have an online playground where you can try out, and you see 3 versions of the source code. So you type in the ReasonML source code, then below it you see the OCaml version of it, and then to the side you see the JavaScript version. So you can check kind of the quality of the generated JavaScript, what that looks like. And the other advantage of this online playground is if you look for material on at the moment there's not yet as much material on ReasonML on the web, but there's a lot of nice stuff on OCaml, so you can read something on OCaml, get a code example, paste it into the playground, and then see it in ReasonML syntax. So that kind of helps you with live translation when you read OCaml code. Writing Node.js-based shell scripts is a pretty neat way of, without having to learn too much to get started. Visual Studio Code I've already recommended. And ReasonML also comes with the built-in tools for scaffolding. So with this command, for example, you get a first Node.js-based ReasonML app, and that makes it easier to get started. Documentation is available too. So the online docs are really nice, easy to read, give you a good overview of what everything means at the moment of the ecosystem. Material on OCaml I've already mentioned, and this is a series of blog posts that is an introduction to the language, and that one is by me. All right, so that's the end of my talk. Thank you.